Hi everyone. Today we are going to be covering day 2 in Unit 4. These notes are available in Unit 4, Day 2 folder. We're going to be talking about the triangle midsegments and inequalities in triangles. So we're going to first start by talking about the triangle midsegment. A midsegment of a triangle is a segment that connects the midpoints of two sides of a triangle. Remember, midpoints are points in the middle. So for example, here D is in the middle of side AB, and I know that because AD and DB are congruent. E is the midpoint of side BC because BE and EC are congruent. So the points D and E connected, they create a midsegment. Oops, that's not a D. DE is our midsegment. All right, now if a segment joins the midpoints of two sides of a triangle, then that midsegment is going to be parallel to the third side and half as long. So in this diagram, if DE is a midsegment of triangle ABC, then that means that DE is going to be parallel to AC. So these have to be parallel. And DE, its length will be half of whatever AC's length is. If you don't like the half and you'd rather write it as 2 DEs equals the length of AC, it means the same thing. So if AC equals 20, then D equals 10. If D equals 5, then AC would have to equal 10. Okay. So whatever the length of DE is, it's going to be half of AC. So looking at example 1, it says to identify all pairs of parallel segments. And I can see that W is the midpoint of QS, since I've got some congruent parts here. X is the midpoint of QR, since these are congruent. And Y is the midpoint of RS, since these are congruent. So I've got 3 midpoints that are all connected. So these are all midsegments. So we can say that XY is going to be parallel to QS. And we could say that XW will be parallel to RS. And the last one, WY will be parallel to QR. Okay, notice how I used the colors to identify that. You are welcome to do that also. Go ahead and try number 2. Tell me the pairs of parallel segments you see there in number 2. Okay, go ahead and check what you have there on yours. You should have JK parallel to FH, KL parallel to GF, and JL parallel to GH. You could have had those in like a different order, but as long as the pairs were together, that's fine. Right, in number 3, it says that L, M, and N are the midpoints of the sides. So I'm going to go ahead and mark those in the picture. So if L is the midpoint of the side, that means these two pieces are congruent. If M is the midpoint of QR, then QM will be congruent to MR. And if N is the midpoint of PR, then PN and NR will have to be congruent. It says that PR is 56. So I'm just going to go ahead and label this whole side as, 46. Whole side's 46. PQ is 40, so this whole thing is 40. And LN is 17. Oh, that's this piece right here. All right. Well, now I can find all of the other pieces that in the triangle. If the whole length of PQ is 40 and PL and LQ are congruent, that means that each of these pieces have to be 20 because they have to be the same size and they have to add up to 40. Likewise, PR is 46, so each half has to be 23. Okay, so now we need to be able to find QR. Well, we learned that a midsegment is half of the side that it's parallel to. So this is 17, which means that that's half of QR. So 17 times 2, this whole thing is 34. Along that same idea, we can now find LM. Okay, well, because this whole side here is 46, then LM, the midsegment that's parallel to it, has to be half of 46, or 23. And then to find NM, well, NM is parallel to PQ, and half of PQ is 20. Now I have all the numbers to fill in my blanks over here. LM was 23, MN is 20, QR is 34, and MR, well, MR has to be half of 34, so that's 17. All right, try number 4, just do A, B, and C. We'll talk about D once we know these missing pieces. So go ahead and try number 4, part A, B, and C. Try that now. All right, so for CE, you should have gotten 14, DE is 18, and FH is 12. They told me that FG was 9. So because FG was 9, I know that ED is 18. It has to be twice as long as the midsegment that it's parallel to. And each half of it, then of course, is also 9. It told us that GH was 7. So if GH is 7, that means that CE has to be twice 7, 14. So that means that each piece of that has to also be 7. And then it told me that CD was 12. So each half of that has, or there's 24. CD has to be 24, so each half of that has to be 12. So since each half there is 12, or half of 24 is 12, we know that FH is 12. So I said that we would talk about the perimeter together. So perimeter of a triangle is the sum of the pieces on the outside. So you have 2 options to do this. Personally, I like this way better. You're going to find the length of each side and add them together. So you only have to add 3 numbers together. So you could say 24 plus 18 plus 14 to get your perimeter, you get 56. The other thing that you could have done was you could have added all the little pieces together. 12 plus 12 plus 9 plus 9 plus 7 plus 7. You're still going to get 56. Okay, so remember, perimeter is the sum of the outside. And since this was the perimeter of triangle CDE, we wanted that whole big triangle. Now, what if we see some algebra with it instead? Not a big deal. In my picture, I see a midsegment, and I know that midsegment is half the length of the side that it's parallel to. So this 7x is going to be half of the 17x minus 18. You have 2 ways that you can set this up. Okay. First, we know that the midsegment is going to equal half of the side that it's parallel to. Or we could say 2 times the midsegment is equal to the side it's parallel to. If you don't like that half and you want to just multiply both sides by 2 to get rid of it, you're more than welcome to. I'll solve it both ways and you can decide which way you like. So way 1, the midsegment is half of the side that it's parallel to. Distribute your 1/2. So half of 17 is 8.5. Half of 18 is 9. I'm going to, let's subtract an 8.5 from both, 8.5x from both sides. That leaves me with negative 1.5x equals negative 9. And I'll divide both sides by negative 1.5. So remember, a negative divided by a negative is positive. And so when we do that, we get 9 divided by 1.5, and we get 6. Now, personally, I don't like dealing with that decimal. As soon as I distributed that 1/2, I ended up with that decimal. So I like the second equation better personally. That's just a personal preference. I can say 2 times the midsegment equals the side that it's parallel to. You might find this a little easier to solve algebraically also. Subtract 17x from both sides and then divide by -3. And we get the same answer. You can decide which way you like better. Do you like it with the 1/2 and distribute the 1/2? Do you like it with the 2? Either way, you get the right answer. So you use whatever you like best. Okay, try number 6. Solve for x in number 6. So you should have gotten x equals 14. I used the second equation where I multiplied the midsegment by 2 and set that equal to the side it was parallel to. If you'd like to check your answer, it's always a good idea to take that whatever your x equals and plug it back in. So we can take 6 times 14 and add 31 to it, and we get 115. And then take your 14 and plug it in at the top. So 19 times 14 minus 36 and 230. This can help you logic through whether or not your answer makes sense. Does it make sense that this piece is half of this piece? And it does. If you set up your equation wrong, then when you plug in your x, you're going to get a number for your midsegment that is twice as long as the side. Well, clearly the side is longer than the midsegment, so it needs to be twice as long than the midsegment and not the other way around. So it's a good way to check also. Okay. Then they might get tricky on us, and instead of finding x, they're asking us to find a length. It's the same idea. You're going to find x, so 2 midsegments equals the side that it's parallel to. Distribute your 2. I'm going to subtract 8x from both sides. Add a 25 to both sides. And divide both sides by 3. We get x equals 9, which is wonderful. And if this was a multiple choice question, 9 would be there. But we need to make sure that we answer the question and find DE. So DE is going to be 4 times 9 plus 1, 37. There's our final answer. And if you wanted to check, you could plug it up in here too. 11 times 9 is 99, minus 25 is 74. That makes sense. The midsegment is half the side that it's parallel to. Go ahead and try number 8. Find RT. Do that now. Okay, so RT was 86. If you got x equals 4, that's great. Just don't forget to plug it in and find the length of RT. And if you'd like to check your algebra, you're welcome to check it with what's on the screen. Okay. You may also be asked to find the perimeter given some midsegments. It says that MN, NO, and MO are midsegments. That's great. Let's find the perimeter of the big triangle. I always like to start with the numbers that are given to me. So like NO is 42. So that means that KJ has to be twice that, 84. And you could even say that these two pieces are 42 if you needed to. Then I see that MN is 49. So that means that JL is twice 49, which is 98. And each of these little pieces here is 49. And then the tricky one is to find the length of KL. So we're going to use a little algebra for that. I know that 2 times the midsegment MO, or 6x minus 1, has to equal the length of KL, 13x minus 10. Distribute your 2, and we're going to solve for x. Subtract 12x from both sides and add a 10. So x equals 8. I'm going to take that and plug it in here. 13 times 8 minus 10. So the length of KL is 94. So to find the perimeter of the whole big triangle, we'll take each length, so the length of JK the length of JL and the length of KL, add those together, and that will be my perimeter. So our perimeter is 276. All right, so that is using midsegments and finding the perimeter. What if we're talking about angles? All right, well, all of the stuff that we learned about parallel lines is still fair game. So if this is a midsegment, and it is, it's connecting the midpoints. That means it's parallel to this line. And I could call this a transversal. So remember, corresponding angles are congruent when their lines are parallel. Alternate interior angles are congruent when our lines are parallel. Alternate exterior angles are congruent when our lines are parallel. And consecutive interior angles are supplementary when our lines are parallel. So looking here, I can tell that angle 1 and angle 2 are going to be congruent. Whatever they are, angle 1 and angle 2 are going to be congruent. And, well, I also see a linear pair. Remember, a linear pair are two angles that together make a line. So right here, angle 2 and 127 form a line. So they have to add up to 180. So subtract 127 from both sides, and I know that angle 2 has to equal 53 degrees. But because these lines are parallel, and this would be a transversal, angle 1 and 2 are corresponding. So angle 1 would have to be congruent to angle 2. Okay, now we got to figure out angles 5 and 4 and 3. So let's see here, more parallel lines. These are, well, not more, but these are the parallel lines. Here's a transversal. Oh, these two angles are consecutive interior angles. Consecutive interior angles have to add up to 180 degrees. So when I subtract 59 from both sides, I get the measure of angle 5 is 121 degrees. Okay, well, angle 4 and angle 5 make a linear pair. So 121 plus angle 4 has to equal 180. Or maybe you recognize that this 59 and angle 4 were corresponding. And so either way, we get that the measure of angle 4 is 59 degrees. And now the last one, angle 3. Let's get rid of some of this mess here. All right, let's find the measure of angle 3. Last class, we learned the triangle sum theorem. The triangle sum theorem says that the three angles in a triangle must add up to 180. So whether you look at the small triangle or the big one, I'll look at the small one, these three angles have to add up to 180. We know that angle 2 is 53, and we know that angle 4 is 59, so we just need to find angle 3. Okay, so we could add 53 and 59 and then subtract that from 180. And when we do, we get the measure of angle 3 is 68 degrees. All right, so lots of stuff is coming back from previous units. Linear pairs, we need to remember that linear pairs add up to 180. Corresponding angles are congruent. Consecutive interior angles, they're supplementary. And the sum of the three angles in a triangle is 180. We use all of those ideas to solve for these 5 angles. Try number 11. See if you can figure out the measure of angle 1, 2, 3, 4, and 5. See what kind of angle relationships you can find. Can you find a linear pair? Can you find one of the relationships with parallel lines? How about the triangle sum theorem? Try those, and then we will talk about them. Do that now. Okay, so for number 1, you should have gotten 62. Because angle 1 and this 118-degree angle, they are a linear pair, so they have to add up to 180. Angle 2, well, let's see, in angle 2, you can say that you have this triangle. Here it is. You know one of the angles is 95, and we just said the angle 1 was 62. So those three angles, that's a 2. Those three angles have to add up to 180. So when you solve for angle 2, you get 23 degrees. And then once you know angle 2 and angle 3 are a linear pair. They have to add up to 180. So you can get angle 3 is 157. Angle 4 is corresponding to angle 2. So they have to be congruent. So angle 2 and angle 4 are the same measure. So angle 4 is 23 degrees. And then angle 5 and angle 1 are corresponding. They're the same. So they are both 62. All right, and number 12, these two angles are labeled and the font was too big to fit in the actual angle, so that's why they're pointed to with those arrows. But as long as this is a midsegment, that means that it's parallel to the side. And now I've got a pair of corresponding angles. And as long as those lines are parallel, our corresponding angles are congruent. So now we can solve for x. Subtract 7x from both sides, add 11 to both sides, divide by 3. And number 13, the angles that are labeled are here and here. Well, these two lines are parallel, and here would be your transversal. So this angle relationship are actually consecutive interior angles. And consecutive interior angles are not congruent, they're supplementary. So we're going to add these two together, and they're going to sum to 180. Combine our like terms, add 28 to both sides. Yeah, we add 28 to both sides. 108. And then divide both sides by 16. All right, now this one might be one that throws students off because you want to make them equal. They're not equal, they're supplementary because they're consecutive interior. So just watch out for that. Go ahead and try number 14 and number 15. Solve for x in number 14 and then plug it in and tell me what the measure of angle CBF is. And then in number 15, solve for x and tell me what is the measure of angle RTV. Try those now. All right, so for number 14, you should have gotten x equals 9. Those two angles had to be congruent because they are corresponding. And then when you take your 9 and plug it in for angle CBF, you should get 83 degrees. Number 15, the two angles labeled are consecutive interior, which means that they are supplementary. So you should have added them together to get 180 and got x equals 25. When you take that 25 and plug it in for angle RTV, you should get 29 degrees. All right, I don't know why there's a blank page in the PowerPoint. My apologies. Here we go. Triangle inequality theorem. So the triangle inequality theorem says that a triangle exists if the sum of the smaller sides is larger than the third side. Let me write that down and then I'll explain it. So hold on one second. So a triangle exists if the sum of the smaller sides is larger than the third side. Okay, so in number 1, let's determine if this triangle actually even exists. So we need to find our small, medium, and large sides. So 8 is the small side, 17 is the medium, and 14 is the large side. Right, because 8 is smaller than 17, which is smaller than 24. If you add the small and the medium side together, they have to be greater than the larger side for that triangle to exist. So 8 plus 17 is 25. 25 is greater than 24, that's true. So this triangle does in fact exist. In number 2, my small side and my medium side are tied, so it doesn't matter which one's which. But when I add those together, they have to be greater than the large side. But 6 is not greater than 7, so this triangle doesn't exist. I cannot have a triangle that has sides of 3, 3, and 7. Let's do number 3. The small side here is 12, and the medium side is 25, and the large side is 35. 12 plus 25 is 37. 37 is greater than 35, so this is a triangle. And now number 4, the small side is 37, the medium side is 42, and the large side is 52. So you want to make sure that your small plus your medium is greater than your large. If that's true, then you have a triangle. 37 plus 42 is 79. 79 is greater than 52. So yes, this is a triangle. Try number 5, 6, 7, and 8. Try those now. All right, so for number 5 and 7, those triangles did not exist. And number 6 and 8, those triangles do exist. Remember, 50 equals 50, but it's not greater than 50. 50 is not greater than itself, so that would not be a true statement. Okay, so just watch out for that. Sometimes they try to trick you and give you the same number on both sides. A number is not greater than itself. A number has to be equal to itself. If you would like a video explaining and showing you more about the triangle inequality theorem, you can click on the link that should appear on your Play Pause It Now, and I will also post it to OMHS for you. Okay. So now what happens if I give you 2 sides of a triangle? Could you find the third side? And now that third side has to have a range. It's not going to be an exact number, because what if I drew a triangle like this, right? Here's 14 and here's 22, and here's the third side. But what if I drew 14 and 22? Here's the third side. Clearly that third side is not the same length in both of these. So you're not going to give me a single number as the third side. You're going to give me a range. You're going to tell me what is the absolute smallest it could be and the biggest. So to do that, what you're going to do is you're going to add the numbers together and you're going to subtract them. You're going to set up a range, and you're going to say that third side has to be greater than some number, but less than another number. So here you're going to find the difference between the two, and then you'll find the sum. So if you find the difference between 14 and 22, that is 8. 8 is going to have to be less than the third side. And that third side is also going to be less than, now you're going to add 14 and 22, 36. So whatever that third side is, it has to be bigger than 8 and less than 36 for that triangle to exist. Okay, so subtract the 2 numbers, that's what will go as your lower bound. Add your 2 numbers, that'll be your upper bound. So I like to usually just set up my answer before I even do anything. X is greater than a number and less than a number. Subtract your 2 numbers, 31 minus 28, you get 3. Add your 2 numbers, 31 plus 28, you get 59. Okay. So you're going to subtract at them. That'll be less than your third side, which will be less than when you add the 2 sides together. So in number 11, subtract your 2 numbers, we get 8, and add your 2 numbers. So if I gave you 2 pieces of string, one was 3 inches long and one was 11 inches long, I asked you to create a triangle and tell me the length of the third side, that third side would have to be bigger than 8, but less than 14. Go ahead and try numbers 12, 13, and 14. So for number 12, you should have 26 is less than x is less than 64. 13, you should have 17 is less than x is less than 31. And number 14, you should have 9 is less than x is less than 25. And if you would like a video that kind of re-explains and goes into this a little bit more depth, you're also welcome to check out the Khan Academy video, which I will post in this Playposit, and I'll post on OMHS also. Now, you could also be given a problem like this, where it tells you that the triangle has these two lengths, and you have to pick all of the sides that meet the requirement for the third length. So all you're going to do is write your range. So subtract your two numbers, 27 minus 15 is 12, and then add your numbers, 27 plus 15 is 42. This says that the third side has to be bigger than 12, but less than 42. So you're going to pick all of the sides that are bigger than 12 and less than 42 at the same time. So 18, 29, 34. I'm not going to pick 12. 12 is not bigger than 12. 12 equals 12. So they're trying to trick you there. 12 is not an answer. And of course, 43 is not less than 42. So number 16, if I give you the lengths 45 and 9 centimeters, which of these could be possible lengths for that third side? If you got the range 36 is less than x is less than 54, then you set up your range correctly, and you should have chosen only 47 and 39. Now we're also going to talk about ordering angles. The angles of a triangle can be put in order by comparing the sides. The smallest angle will always be opposite the smallest side. So if I look here at this triangle, the smallest angle will be opposite the smallest side. Well, the smallest side is 7, so the angle opposite it is angle A. That's going to be my smallest side, or smallest angle. The largest angle will be opposite the longest or largest side. So the largest side here is 13, so the angle opposite that is angle B. That's my largest angle, meaning C has to be the medium. Because 10 is the medium side, C would be the medium angle. So if I wanted to list the angles in order from least to greatest, I would say angle A, angle C, angle B. A is the smallest, C is the medium, and angle B is the largest. Ordering the sides is just the converse of that. The shortest side is opposite the smallest angle, and the longest side is opposite the largest angle. Sometimes they'll get tricky on you and only give you 2 angles, but we know that these 3 have to add up to 180. So if I just do 180 minus 103 minus 42, that tells me the measure of angle F is 35 degrees. Now the smallest of those 3 is 35. So ED will be my shortest side. 42 is the medium-sized angle, so DF will be the medium-sized length side. And angle D is 103, which means that EF is my longest side. So if I want to order the sides from least to greatest, I can say side DE, side DF, side EF. Always make sure you follow the directions because sometimes they might say greatest to least. So just read those directions carefully. All right. So here I want to order the angles from least to greatest. So my smallest angle will be across from the smallest side. The smallest side here is 17. So my smallest angle is angle M. My medium side is 20. So the medium angle will be angle P. And my longest side is 24. So my largest angle is angle N. Try number 2. Order these angles from least to greatest. Try that now. You should have angle T, angle R, angle S. The smallest side was 30, so the angle across from it here is angle T. The medium side was 35. The angle across from that is angle R. And my longest side was 38 inches. This angle across from that is angle F. Sometimes students ask me, how do you know what angle is across from it? Well, it's the angle that's not touching it. So like if I'm looking at side 30 or RS, there's only one angle in this triangle that is not touching 30, and that's T. So that's the angle that's across from it. And number 2, we're going to order the angles from least or from greatest to least. So it's the same idea. It's just we're going from greatest to least. So my longest side is 11. The angle across from it, or not touching it, is angle C. My medium is 9. So the side or is across from the medium angle, which is angle B. And my smallest side, 8, that's across from angle D. All right, try number 4. Order these from greatest to least. All right, so you should have angle X, angle Y, angle W. Make sure you read those directions carefully on assessments, because if you email and say, oh, I just read it wrong, there's really not a lot I can do for you on that. So make sure you read those directions carefully. Now let's order the sides from least to greatest. Notice that all of these triangles are missing an angle. So honestly, at the very beginning of this, I just went through and found that missing angle on all of these guys to make answering it a lot easier. So we just do 180 minus the 2 angles that are given to us. So angle K is 92 degrees. If you want to go through and find angle T, angle Z, and angle E, do that now. Angle T is 59 degrees. Angle Z is 44 degrees. And angle E is 46 degrees. Now that makes ordering these so much easier. The least to greatest says look for your smallest angle. That's going to be across from the smallest side. So KL is the shortest side here. My medium angle will be across from the medium side, JK. And the largest angle, 92, will be across from the longest side. Okay, go ahead and try number 6. Do that now. You should get ST, SV, TV. ST is across from the smallest angle, 53. SV is across from the medium angle, 59. And TV is across from the largest angle, TV. And the next step, we're going to go from greatest to least. So my greatest angle is 82, which means my longest side is XZ, the side across from 82. My medium angle is 54, so my medium length side will be the side across from it, YZ. And my smallest angle is 44, so my shortest side will be across from that, XY. Go ahead and try number 8. What's the biggest angle? So what's the longest side? All right, you should have BE, BD, DE. Please know that on an assessment, sometimes they make the triangles look wrong, okay, because they're testing. Do you know the numbers, not just on how a picture looks? They might make a side look longer than another side when it actually isn't. So always go by the numbers, not just by how the picture looks. And the last part of the lesson today is our Hinge Theorem. The Hinge Theorem says that if 2 sides of a triangle are congruent to 2 sides of another triangle, and the included angle of the first is larger than the included angle of the second, then the side opposite the angle of the first is larger than the second opposite the angle of the second triangle. What? All right, that's a lot of words. But what it's saying is if you have 2 triangles here with some congruent sides, right? So these are congruent. These are congruent. Okay. And what's happening is those sides are hinging back and forth. They could move. Think of it like a door. Okay. So what's going to happen is this angle in between could change, right? This angle is not going to be the same if I move my blue and my red pieces back and forth. So it says that if the measure of angle A is greater than the measure of angle D, So if this angle is bigger than this one, then the sides across from it, side BC, will be greater than side EF. That's all that means. Okay. The converse of that says that if this side BC is bigger than EF, then the angles across from it will have the same relationship. So the measure of angle A will be greater than the measure of angle D. So if all those words over there kind of freak you out a little, don't worry about them. Just know that as you open up the angle, the side across from it is going to get larger also. And now you might also see why I put the little arc through my angle symbol when I write, so I don't get it confused with these less than and greater than symbols. All right, so let's look here. We'll use red. I have 15 and a 15 and a 9 and a 9. So I have two sets of congruent sides. But this angle is 79 and this angle is 74, which means the side across from the larger angle is going to be greater than the side across from the smaller angle. So since 79 is bigger than 74, that means that KL is going to be greater than PM. Simple as that. In number 2, I see 24 and a 24, and they share this side, so that's going to be equal to itself. So now I see 59 and 65. 59 is smaller, 65 is bigger. So that means that BC is going to be greater than AD, or AD is going to be less than BC. Okay. Let's see, in number 3, I see a side 3 and a side 3, and they share this side here. But we don't know this angle. This is the angle we need. So let's use our triangle sum theorem to find any missing angles that we can. Well, I see in this triangle 2 of the angles. So I'm going to do 180 minus 93 minus 32. And when I do that, 180 minus 93 minus 32, I get 55. So this is really the angle that we are looking at. So I've got 3's congruent, xz congruent to itself. 53 is the angle across from xy, and 55 is the angle across, or 53 is across from xw, and 55 is across from xy. I like to use S and L, right? A smaller, larger. So WX has to be smaller than XY. So I put a less than symbol there. All right, well, in number 4, I see a linear pair. So if I do 180 minus 83, that tells me that this angle right here is 97. So what's going to be bigger? QP or PQ or PS? Which one's going to be bigger here? Okay, if you said that PQ was going to be larger, you're right, which means we have to put a greater than symbol there. Go ahead and try these. Try number 5, 6, 7, and 8 on these. Do that now. Okay, so for each of these, you needed to look at the angle and then look at the side across from it. If the side across from it was bigger, then it was the bigger angle. For number 5, you should have greater than, 6 greater than, 7 less than, and 8 less than. And if you'd like to talk more about any of this in office hours, I will be available on Tuesday at noon. There are practice problems also available to you on OMHS. And I did not say the attendance board out loud, but it did pop up in the play pause it. So hopefully you got that. And then don't forget to do the exit ticket. Have a wonderful day, everyone.